When geometry meets physics, discover the geometric intuition of the dot product with the classical cube problem. Hi everyone. Today we're diving into a classic problem that connects the beauty of geometry with the precision of vector analysis in problem 1.5. Find the angle between a body diagonal of a cube and any one of the face diagonals. Hint, choose a cube with side 1 and with one corner at the origin and with the opposite corner at point 111. Of course, in this problem, we're going to generalize it because we don't always see a perfect cube. Write down the vector that represents a body diagonal and another that represents a face diagonal, and then find the angle between them as we did in the last problem, problem 1.4. Alright, so let's set the stage. Imagine a cube with the side length a instead of 1, and we see that at the origin is at 0, 0, 0, and the furthest point away is at a. What's the relationship between these two diagonals, where blue is the body diagonal and green is the face diagonal? Okay, and more importantly, how can the dot product help us find the angle between them? So, the body diagonal stretches from 0, 0, 0 to a. Okay, so its displacement vector is the terminal point, the point it ends at, minus the initial point. And if you've taken a vector calculus class, this should look familiar. But as we see, taking the difference component-wise leads us to a body diagonal vector of a. Pretty easy. We like that. And for the face diagonal, if we put it on this side face here, it goes from 0, 0, 0 to a. So pretty much the same thing, terminal point minus the initial point. We see we get our two vectors here. Pretty simple, right? Simple enough at least. So if you're finding this breakdown helpful so far, give this video a thumbs up and share it with someone who might benefit from it. But now let's get to the angle. So now let's find the angle between these two vectors using the dot product formula derived last video, which was cosine of theta equals b dot c over the magnitudes of b and c respectively. Solve this for theta and put in the component forms where we see the algebraic definition of the dot product and the definition for the magnitudes respectively. So what we see here, now that we have our two vectors defined, pretty straightforward. We have a from the body diagonal and a from the face diagonal, and then we take their magnitudes respectively. Color coordinating makes this pretty easy. Simplifying it, of course, we get a bunch of squares with a's in them. A squared, 0, and a squared, and then a all squared, a0, a squared. And so simplifying this down, we get 2a squared in the numerator, 3a squared in the b diagonal, and then 2a squared in the c face diagonal. Go ahead and simplify this even more. We see that since we're both in the square roots here, we can multiply the insides of the arguments. 3 and 2 give us 6, and then we have a squared twice, so that's a squared squared. Since this is a square, we could take the a square out, and then we see we cancel and cancel. As a cube, you would expect this to happen since all dimensions are the same, and we can cancel them out, and we see that we get the same result anyways, had we just put a equal 1. And what that result is 35.26 degrees. But what does this really mean? Well, the dot product gives us a way to measure how much one vector points in the direction of another, assuming that, again, we have our magnitudes that we can calculate. And with the degree measurement of 35.26, it shows that the body diagonal and face diagonals are relatively close but not perfectly aligned. And this problem isn't just about numbers, it's about building geometric intuition for vectors and their relationships. Again, dot products will be embedded in this class over and over again, and in fact in many other classes, so you might want to build the intuition early and reference it often. So if you're passionate about understanding classical mechanics, hit that subscribe button so you don't miss my next video in the series. Huge thanks to my Patreon supporters. Your backing enables me to create in-depth physics content. Your support truly drives the channel forward. If you want to support this physics exploration, check out the Patreon link in the description and join the scientific journey. As always, thank you for watching, and until next time, stay curious.